Hey guys, how is everybody? Hope you're all well. We're on lesson 7 of our function unit. So our objective is that we're going to be now deciding if situations are linear or nonlinear. So it's like we're given a word problem. And from that word problem, we'll have to decide if maybe there's a constant rate of change or not. We have already talked about that linear functions, if graphed, make a straight line. If it's not graphed, then there are other ways of deciding whether it's linear or not. If we're given an equation, really you should just be looking at the exponent. Remember, linear equations have an x in it whose exponent is 1 and sometimes 0. If the exponent is something like 2, 3, 4, or 5, so on, then it's nonlinear. Also, what we saw in equations is that if the x variable is in the denominator, it happens to be nonlinear, and that's because when the x is in the denominator, its exponent is actually some negative value. So therefore, it's not a 1 or a 0. When we're given a table of values, we learned that we can find the rate of change. Rate of change is like finding the slope, remember, the change in y over the change in x. If the rate of change is constant, then it's linear. If the rate of change is not constant, then it's not linear. So depending on how the problem is presented to you, depends on what you look at to decide linear or not. So you have a do now, which is all of page 37. It'd be great if maybe you gave it a shot before you watched me do it. And of course, you'll be checking your answers from the previous lesson. I will be doing the do now and the development with you. At the end of this lesson, we'll be able to see if a function's linear or nonlinear given a situation. And your homework really is the problem set, which is on pages 40 and 41. So here's our lesson about situations, but really the do now is not situational. The do now is what you've done. So that's why I said it'd be great if maybe you gave it a shot before you watched me do it. So it's asking us to decide first if it's a function or not. So some of you messed up um, explaining whether something is a function or not, or explaining whether something is linear or not. Those are two different questions. So first, in part A, it's asking, is it a function? So to determine if something's a function, every input has to have one output. The inputs, remember, are your x values. The input of 4 only has an output of 9. The input of 5 only has an output of 11. The input of 6 only has an output of 13. The input of 7 only has an output of 15, and the input of 8 only has an output of 17. Each input has one output. So yes, this is a function. And your reason should be each input has one and only one output. That really is the only acceptable reason. Next, in C, it's asking if it's linear or nonlinear. So some functions are linear, some functions are nonlinear. Some functions have a constant rate of change, and some functions don't. They're all still functions, it's just that if I graph them, sometimes it makes a straight line, sometimes it makes a curve. So it says show or explain how you came up with your conclusion. I don't have a piece of graph paper here, so I'm not going to graph this. I'm going to look at the table and check out the rate of change. I'm first going to look at the change in y. From 9 to 11, it went up 2. Then I'm going to look at the change in x. From 4 to 5, it went up 1. If I wrote the first rate of change, remember, rate of change is change in y over change in x. My first rate of change is 2 over 1. Next, from 11 to 13 goes up 2. 5 to 6 goes up 1. Second rate of change is 2 over 1. So far looks constant. You can't decide if it's constant until you look at the entire table though. Up 2, up 1, 2 over 1, up 2, up 1, 2 over 1. The rate of change is the same the whole way through, therefore we say it's constant. So linear or nonlinear? It's linear. Because the table shows a constant rate of change. Now there's something else I have to point out. I wouldn't be able to make this statement without showing this work. You can't just say there's a constant rate of change without showing me what the rates of change are. So some of you are not showing everything that needs to be shown. You have to find all of the rates of change, and then from those rates of change you could decide if it's constant or not. You don't know if it's constant or not until you look at every single one. So when you're taking a test or a quiz, you have to show all the rates of change, and then you have to make a statement. Mandatory. Go back to this video and listen to what I just said multiple times so that you know how to state if something's a function or not, and you know how to state if it's linear or not. Finally, it's asking us to make the rule. Now remember, this is linear, so linear functions can be written in the form of y equals mx plus b. Only linear functions are written in the form of y equals mx plus b. M is the rate of change, so I already know part of this. I know it's y equals 2x. The only thing I don't know is this b. So why don't you just think about it logically? If these are the points on this graph, what does that blank have to be? Let's pick the very first thing. My y is a 9. My x is a 4. What does this blank have to be? You can do this algebraically, or you could use your common sense. 2 times 4 is 8. I need to get 9. What's this blank? Yeah, it's a 1. Okay, so use some common sense. The equation must be y equals 2x plus 1. Test it with another point. Let's go and test it with the 715. If I put in a 15 in place of y, and if I put in a 7 in place of x, and I have this plus 1, does it work? Yeah, it does. Okay, so some common sense. Math is common sense, believe it or not. So some of you think that math is this strange stuff. No, it's just what always makes sense. So use your common sense, and then you can do the math. So in number 2, is it a function or not? 0 has an output of 0. 1 has an output of 1. 2 has an output of 4. 3 has an output of 9. 4 has an output of 16. Each input only has one output. Yes, it's a function. So when it comes time to grading the test, right, you just took your quiz. There was a little leniency going on with that quiz, but when you take your test, if you're asked if something's a function, you say yes because each input has one and only one output, or you say no because there are some inputs that have more than one output. Like there's only one statement. It's that every input has to have one and only one output. Now they're asking if it's linear or not. I'm given a table. The only way to determine from a table is by looking at the rate of change. This goes up 1. This goes up 1. My first rate of change is 1 over 1. This goes up 3. This goes up 1. My next rate of change is 3 over 1. I can stop already. I can continue going on with the table, but as soon as I find that there's 2 rates of change that are different, it's not constant, therefore it's not linear. So it's nonlinear because the rate of change is not constant. Constant means it's the same the whole way through. Now it's asking for a rule for the function. Now really this would be more like a bonus on your test because we had told you that we're only going to make you write rules for linear functions and we just decided this is nonlinear. But just think about it. Use your common sense. How can you get from the input to the output? How do you get from 0 to 0? How can you get from 1 to 1? How can you get from 2 to 4, 3 to 9, 4 to 16? Did anyone figure it out? Do you notice you could just square the x? 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. The function is y equals x squared. If you square the x, you get to your y. Now, just noticing that there's only a part A and a part B here and not a C and D is already a hint. Remember, I said math is all about common sense, even the way the question is presented. Use your common sense. Do you see how it's asking if it's a function y or y not? And do you see it's not even asking if it's linear or not? How much you want to bet this one's not a function? And that's why I'm not asking if it's linear or not. You can't tell me if something's linear or not if it's not even a function. Functions are linear or nonlinear. Things that aren't even functions, we don't classify it that way. So let's take a look. The input of 4 goes to 2, but oh no, the input of 4 also goes to negative 2. The input of 4 has two different outputs. The input of 1 has two different outputs. This is not a function. And I'm going to say because the input of 4 has more than one output, and the input of 1 also has more than one output. As long as you find one thing with more than one output, it's already not a function. If we did this as a mapping, and this is something I want to go over because I wasn't thrilled about what I saw in the quiz, I really am going to be stricter when it comes time for the test. When you do a mapping, you need to list the different inputs you see. I see a 4, I see a 1, I see a 0, I already wrote down 1, and I already wrote down 4. You only write down the different inputs. Don't repeat them when we do it as a mapping. As a mapping, you list the different inputs, and then you list the different outputs. I see 2, I see 1, I see 0, I see negative 1, I see negative 2. 4 goes to 2. 1 goes to 1. 0 goes to 0. 1 goes to negative 1. And 4 goes to negative 2. It's these arrows here that there's 2 coming out of the 4 and that there's 2 arrows coming out of the 1 that proves it's not a function. Okay, you can't have 2 arrows coming out of one number because it means that that number is going to 2 different outputs then. So if there's ever more than one arrow coming out of an input, it's not a function. So by viewing it as a mapping, we can see that it's not a function. So hopefully that clears up anything about the past. So now let's go on to our word problems here. So we're deciding if each of the following situations is linear or nonlinear. And then it says explain. So here we go. On Monday, so I'm going to keep track of some things. On Monday, I put 1 penny in a jar. On Tuesday, I put 2 pennies in a jar. On Wednesday, I put 4 pennies in the jar. And on Thursday, I put 8 pennies in a jar. And then you continue the pattern. So that would mean on Friday, notice what the pattern is. I put in 1, then I put in 2, then I put in 4, then I put in 8. Aren't I doubling the number of pennies I put in each day? So I guess on Friday I'd be putting in 16. And this pattern would continue. Am I putting in the same number of pennies every day? Is my rate of pennies increasing by the same amount each day? The answer is no. This is non-linear. And it's non-linear because the number of pennies that I put in each day is not constant. The number of pennies I put in each day is not growing at a constant rate. How about that? Or not increasing. If I were to look at how it's growing, it went up by 1 penny, then it went up by 2 pennies, then it went up by 4 pennies, then it went up by 8 pennies. And like Monday could be considered day 1, Tuesday's day 2, day 3, day 4, day 5. So the days are increasing just by 1 each time, but the pennies are increasing differently. If I were to write the rate of change, first I'd have 1 over 1, then I'd have 2 over 1, 4 over 1, 8 over 1, and so on. So the pennies are not growing at a constant rate. If you were to graph this, it would like make a curve. So definitely not linear. It's because the rate of change is not constant. Number 2 can be tricky, so let's pay close attention. So you're having a candlelight dinner at 5 p.m. So I'm going to keep track of this. You light a beautiful candle. Now they don't tell me how tall it is, but I have a nice full candle. At 5:30, you notice that the candle is 2.5 centimeters shorter. So since they're talking about that it decreased by 2.5 centimeters, they're talking about the rate of change. So even though I don't know how tall this candle is at 5, and I don't know how tall the candle is at 5:30, I do know that the change was a decrease of 2.5. So they're already telling me that it changed by 2.5 centimeters in half an hour. Next, they're talking about 6:30. So I'm going to like put a 6 here and then a 6:30. I don't know what it is at 6. I don't know what it is at 6:30. But I notice that the candle is 5 centimeters shorter than it was at 5:30. So from here to here, it decreased by 5 centimeters. So now I have to think, is that a constant rate of change so far? From 5 to 5:30, it decreased by 2.5, and that was only a half an hour. So from 5:30 to 6:30, it decreased by 5. Is that constant? And hopefully you're saying, yes, it is. From 5:30 to 6:30, it could decrease by 2.5. And then from 6 to 6:30, it could decrease by 2.5 because 2.5 and 2.5 is 5. So far it really is a constant rate of change. Let's continue. At 8 p.m., you find the candle is 15 centimeters shorter. So there was a 7, a 7/30, and then an 8. And it's 15 centimeters shorter than the original. So way back from the beginning, all the way down here, it decreased by 15 centimeters. Is that constant? Let's go by each hour again to make things a little bit easier, because we saw in 1 hour it actually decreases by 5 centimeters. So if from 5 to 6 it went down by 5, and 6 to 7 another 5, and 7 to 8 another 5, down by 5, down by 5, down by 5. Isn't that down by 15? So this one was a tricky one to think about, but really the candle is burning at a constant rate. Yes, this is linear. The candle is burning at a constant rate. It seems like we could say it decreases by 2, that's not working well, 0.5 centimeters every half hour. Or we could even say decreases five centimeters per hour. But definitely linear, constant burning. Number 3, assume the pattern continues to grow in the same manner. So let's count how many blocks there are. 1, 2, 3, 4, 5 in the first size. 1, 2, 3, 4, 5, 6, 7, 8 in the second size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in the third size. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 26 in the fourth size. So it went up one size each time, size 1 to size 2 to size 3 to size 4, but the blocks increased by the same rate each time. From 5 to 8 blocks, it increased by 3. From 8 to 14 blocks, it increased by 6. From 14 to 26 blocks, it increased by 12. Is that a constant rate of change? The answer is no. It's nonlinear because the rate at which the blocks are growing is not constant. I said blocks are growing. We could also say blocks are increasing. And again, I wouldn't be able to make any of these statements about constant or not constant without showing the numbers that I showed on the problem. So it's so important that you show work along with your statement. We have 2 more problems. One is about area and the other about perimeter. So the area of a rectangle is 16 square feet. First it says write an equation using L for length and W for width. So remember that area of a rectangle is length times width. Then it says create a table of values for possible dimensions. So we're going to keep our dimensions simple. Let's keep them integer values. I have to think of a length and a width so that if I multiplied them, I would get an area of 16. So what times what is 16? You might be thinking 4 times 4. You might be thinking 2 times 8. How about even 1 times 16? So why don't we use some of those numbers? What if the length was 1 and the width was 16? Wouldn't like this skinny long rectangle of a length of 1 and a width of 16 give me an area of 16? It would. And then I can make it a little wider and shorter and do 2 times 8. Or I could do 4 times 4. Or I could switch it around and say the length is 8 and the width is 2. Or the length is 16 and the width is 1. So this is a table of possible dimensions, and now it asks us to graph the situation. So notice I have to get up to 16. Let's put the length on the horizontal axis, and let's put the width on the vertical axis. And if I want to get to 16, I have to go by ones. So here is 0. This is one big first quadrant. To label it and not get too squishy, I'm going to call this first mark 1 and the second one 2, but only label every other so I don't get too squishy. And I'm going to do the same thing on the vertical axis. And now we're going to plot these points. So in my table, 116 makes me plot the point 1, 16. And then plot 2, 8, and so on. Take a look at those points. If I connected them, are they a straight line? Well, the answer is no. Okay, you can connect them. My pen's not working so great, so bear with me. This curve might not be perfect. I'm doing pretty good though. Okay, when I get to this 16, 1, it actually comes down closer and closer and closer to the x-axis. And over here, it gets closer and closer and closer to the y-axis. So I am going to put arrows. So after graphing it, I can say it's nonlinear. When it tells me to explain, just refer to the graph. It's not a straight line. Now again, when I was grading your quizzes, some of you told me something, wasn't linear because it wasn't a straight line, but there was no graph to look at. How can you make a statement that the line's not straight if you're not even showing me a graph? Okay, so if you're explaining something is nonlinear because it's not a straight line, I better see a graph to prove it. So again, if I were to go back up to here, none of these did I say the graph's not a straight line, did I? Because I don't see a graph. I had to talk about the rate of change in these problems. So please make sure your reasoning matches whatever work you've done. Number 5, they're asking about perimeter, and now they're making the perimeter 16. And they're telling us to write an equation using L for length and W for width. So what you have to remember about perimeter is that you add up all the sides. A rectangle has 4 sides, so the perimeter of the rectangle would be the length plus the other length plus the width plus the width. That's one way of writing an equation. Or I could say 2 lengths plus 2 widths. And again, they want some possible dimensions. And again, I want to keep it simple. So I'm going to think about, maybe this rectangle, and I'm going to pick this side to be a 1. If that side is a 1, of course the other side is a 1. So far, when I add 1 and 1, I get 2. So what would these two sides have to be so that if I added all of them, I get a 16? I agree, they would have to be 7. Right? If that was 7 and that was 7. 7 plus 7 is 14. Plus the 1 and 1 makes a 15 and a 16. 7, 7, 1 and 1 adds up to 16. So one possible dimension would be 1 by 7. That would give me a perimeter of 16. Now let's pick a 2. What if this was 2? It would make this 2. What would the 2 widths have to be? Yeah, they would each have to be 6. 6 and 6 is 12, 13, 14, 15, 16. I'm already noticing it seems to be making a pattern. I'm not confident though until I try again. What if this was 3 and this was 3? 3 and 3 is 6. So yeah, this would have to be 5 and this would have to be 5. Seems like the pattern works. So if I put a 4 here, does it mean that this one would be 4 too? If all the sides were 4, does that add up to 16? Yeah, it does. What if this was a 5? Would this really be 3? If I had 5 and 5, that's 10. 3 and 3, yep. So there's this kind of pattern going on here. Now it asks us to graph the situation. My numbers didn't get as large this time. The largest one is 7. So I'm going to spread it out a bit more, and I'm going to call this 1. And this is 2, and so on. It's nice to be able to spread out a graph if possible. So this is my length. And I'll do the same thing on this y-axis. And if I plot the point 1, 7 and 2, 6, 3, 5. Are they looking like they form a straight line? Yeah, they do. If I continued this pattern, my next point would be here. If I had a rectangle of dimensions 6 and 2, does that add up to 16? If I had 6, 6, 2, and 2, it does. See, so by making a pattern, you can make these predictions. So really the situation is linear. Asks us to explain, it's because the points land in a straight line. So there's one statement I actually want to make, that area formulas always turn out to be nonlinear. perimeter formulas are always linear. And that is true. So you could keep this in mind for when you're doing your homework and for when you have a future test or quiz. So hope that was helpful. I'll talk to you again soon. See ya. Bye.